Hi, so today I'm going to show you my project for this semester of BMIS, my Rocket League bot. So I'm going to start out here by opening the actual Rocket League bot GUI, or graphical user interface. And this is available on GitHub, and it is a crowdsourced idea/project. And there have been competitions in the past. I don't think there have been any for the last couple of years, but in the past, there have been competitions to who can make the best AI bot at Rocket League. So right now we're starting the GUI up right here. And once we have this going, it is a modded Chrome tab pretty much. And so once this loads, we will be able to see all the different bots available for me to use. Now, these are bots available on GitHub, other places, and the ones where you see an exclamation point are just mean I haven't downloaded it. So right here we have BMIS Prime, and you can see there's a GitHub link that tells you what language it was coded in, Python or C#. So now I'm going to drag, for example, Psionics Pro, one of the pros of the game, and I'm going to drag my bot, AdaBot1. And as you can see, you can go through different options of the map and the mode. And so right here, I'm just going to search for my bot and grab it. And then once we start the actual match, we will be able to see these two AI bots go against each other. And then after this, I'll dive into the code so we can see what exactly is driving it. Okay, so let's get into a game here. I pulled up Rocket League and started a match between the AIs. Now, I just want you to watch my bot, AdaBot1, as it goes against one of the most basic bots there is in the game. So as we can see, I will be switching between different camera angles here. My design bot is the orange car, and we can see that it doesn't simply just go after the ball. It waits for the opponent to drive around, as it did right there. And it doesn't just follow the ball. It uses a combination of prediction algorithms and path planning to navigate the field, and a lot of decision-making logic to choose the best actions based on the game's current state. Oh, and there you go. As you can see, AdaBot1 just scored. Kind of a lucky goal, but as you can see, it understands where the ball is, where the goal is, where the actual bot is on the field. And using that game state knowledge, it's able to put the ball in the net. So as we keep watching here, I just want to go over more of the background behind how this works. So there's a lot of different ways to play this game. You can do aerials, fly in the air, stay back and play defense, get boost to go faster. So there's a lot of strategy and not just simply driving after the ball. Oh, and there we go. My Ada bot scored once again. But yeah, there's a lot of strategy in this game, which makes it a harder AI bot to program compared to a more simple one. But by building in different maneuvers and tactics, which I'll go over later, the bot is able to determine what its best action is at that exact moment, given the state of the game. Even the score could impact what it does. So as you can see, my bot went in pretty fast there, but as it comes back, we'll see some of the defense strategy it has. And it looks like it's doing pretty good. Might get another goal here. Indeed it will. So I wanted to go into some of the actual Python functions that make this work. First up, we have classes. The bot is primarily structured using classes. For instance, the MyBot file inherits from base agent, which is the framework for the bot behavior. We have other classes like default behavior, which inherits from choice, which is kind of how the bot determines what it wants to do at that moment. And this is used to organize and show patterns. And as you can see, the other AI scored. But next we have functions such as the use brain function, which is responsible for most of this decision making. And it goes through a set of different maneuvers or actions it could do and weighs them on a scale of how likely it is to outcome in a good outcome or a bad one. And it chooses the one with the best outcome. And as you saw right there in the gameplay, my bot and right there is going back and playing a little strategic defense, which is not something that the bot does by default. So this took a little this took a lot of understanding of the game and how it works. Oh, and there we go. Scored again. But it takes a lot of understanding of the game to know how it works and what kind of strategy to build into the bot. Okay, so now let's dive into some of the more nitty-gritty about the code of the actual bot. So this is the main file for the entire bot, bot.py, and you can see all the different modules and packages I'm importing and able to let the bot do its thing. And right here, I'm showing the game tick packet, which is how the bot understands where it is, where the ball is, where the other player is. And you can see right here, I'll go into more detail later, but there's different maneuvers and how it chooses its kickoff strategy. And right here is drive towards the ball and return to own goal, two strategies where it decides whether it wants to go towards the ball or away from it to make it more strategic defense. So right here, we can see a lot of different behaviors I built into the bot. And these have been kind of blended and combined from a lot of different bots I found online through GitHubs and YouTube videos. And right here are the controllers. So like driving, flying, shooting. And a lot of these are combinations of other code I found online as well, but kind of modified it and tailored it for my bot itself. And right here is the main one, utilities, the utilities folder. And we can see different functions like tracking how much boost is on the field, the curve of the ball. It's all for the bot to understand what it's doing. And so like this one right here, info, gives a lot of info about the field itself, how the boosts work, how the game works, just a lot of different values of to help the bot understand the game more. And so we can see this code right here, predict.py, is a code to predict where the ball is going to land or when it's going to be hit. Pretty basic vector calculations and arithmetic, but it did take a while to understand. And this is one of the pieces of code I did not write. I did have to get the RL math from a fellow GitHub user since it is very complex, and as well as this one with the vectors. But I did have to modify it a little to fit in with my code base, but I did not write this, but it would be very helpful. And now we can see that I'm just going through all the different mathematical calculations for knowing where the ball is, knowing where it's going to land, and stuff like that. But now if we get into the more into the configuration files, we can see we can change the colors, the cars, and here is just some basic bot configuration stuff, my name, the GitHub link. And of course, going back to our main code snippet, the bot.py script, which controls most of the bot's functions. So we can see that we have these maneuvers, drive, shoot, fly, initializing the actual bot agent, and going back to that, it calculates a lot of the what's going on in the game, grabs that info like around 36 times a second. And so we can see right there, those are its different options for control, rolling, pitch, yaw, and boost. We can also see some maneuvers, such as a kickoff and defense. And so this script is pretty much controlling all the other scripts and telling them and knowing when to call each one. And there's one right there you can see at the bottom, aim, and that is just helping the bot to aim the ball. So pretty much that is my Rocket League bot project. It is available on GitHub, and you can look up RLBot on GitHub as well. But yeah, that is it, and I hope you like it.